Happy Tuesday. Today we're going to be talking about Newton's second law. And your goal for today is to basically be able to use Newton's second law and apply it to real world situations. Okay, so what is Newton's second law? It is F equals ma. And that's it. Force is equal to mass times acceleration of an object. Force is typically going to be measured in units of newtons. And we are going to abbreviate newtons as an N. Mass is typically going to be measured in units of kilograms, which we abbreviate as kg. And acceleration is going to be just A, and we'll abbreviate acceleration to, there we go. Into just meters per second squared. There we go. Cool. All right, so let's try just an example problem so that we understand how Newton's law works. Let's say there's a box. And this box has a mass of 27 kilograms. And we've got a worker who is going to push the box south with 12 newtons of force. What we're trying to figure out in this problem is what is the acceleration of the box. Okay, so we've drawn our picture, we've identified what we don't know, we've identified what we do know, and what we don't know, there we go. So let's write out our equation, F equals ma. Let's substitute the numbers that we know into the equation. 12 newtons equals 27 kilograms times A. And if we divide both sides by 27 kilograms, we solve for A, which in this case would be 0.4 repeating meters per second squared. Okay, so not too crazy, right? This is saying that if a person exerts 12 newtons of force on a box, that box is going to accelerate at about 0.4 repeating meters per second squared. But these problems can get a little bit trickier. For example, what if it wasn't just one person pushing on the box? What if there were two people pushing on the box? Then what would it look like? Well, let's talk about that. All right, so here's our box with 27 kilograms. And we still have a person pushing on the box, and they are exerting 12 newtons of force still. But now there's a second person pushing on the box. And this person is exerting 17 newtons of force. And they want us to figure out how fast is the box accelerating. Well, how would we solve this problem? What we're going to do is we're going to create something called a force vector diagram, which is a really fancy way of saying we're going to draw a picture. So, we're going to use something known as the head to tail method. A vector is basically anything, any number that has a direction. So 12 newtons south is a vector. And the head to tail method basically states that at the end of every head, we're going to have the tail of another vector. So person A is pushing with 12 newtons north, and person B is pushing with 17 newtons east. So at the head of my first vector, I'm going to have my second vector, which is 17 newtons. That's the force being applied by person B. And we can see when we're using this head to tail method, we create a triangle. So using Pythagorean's theorem, I can solve for the net force, or my hypotenuse. Okay, let's do that. A squared plus B squared equals C squared. And 12 newtons squared plus 17 newtons squared equals C squared. I can take the square root of both sides. That cancels out my C squared. And when I plug those numbers into my calculator, I should determine that the net force is 20.8 newtons. Okay, so now I know what the net force, the sum of all forces, is that's being exerted on my box. All I have to do now is use F equals ma. So my force is 20.8 newtons. My mass is 27 kilograms. I'm trying to find the acceleration, so I divide both sides by 27 kilograms. My 27 kilograms cancel out. And the acceleration exerted on the box should be 0.77 meters per second squared. Cool. And there you have it. We could also use things like sine, cosine, and tangent to find theta. We've done that a lot in class, and I'll demonstrate that more in further videos. Cool. Go ahead, try the exit slip, and I'll talk to you tomorrow. See you later. Oh, before I forget, there is going to be a Google Hangouts from 1 o'clock to 3 o'clock. The physics time slot is between 2:30 and 3, so if you want to stop by during that Google Hangouts, either for help on the exit slip for today or for yesterday, or just to kind of touch base on physics, or just to talk, I'll be there. I'll shoot out that invite later in the afternoon on Tuesday. Bye.